Welcome once again to Code Zone KE to another Java session. Today is a little bit of theory and we're going to talk about Boolean because the next session we're going to talk about something that we call if-else, the comparison, when you want to compare one thing to another. So Boolean is all about comparing. When you have a number, an integer, say 1, and you want to compare it with 2. Normally, for the Boolean data types, there are only two answers to it. It's either true or false. Those are the only result of comparing two numbers, of comparing anything when it comes to Boolean data types. It only takes two, that is true and false. And for Boolean data types, there are 6 comparison operators. We call them the 6 comparison operator. The first one is less than. When you say 1 is less than 2, the answer here is supposed to be true because 1 is actually less than 2. But when you say 2 is less than 3, then this one becomes yes, it's also true. But again, if you say, if I invert this one and say 3 is less than 2, of course 3 is less than 2 is false. Reason being 3 is actually higher than 2. So this one is what we call less than. Less than for 2 is less than 2. Normally it will also give you a false because less than does not cover equal to. But the same 2, when you say 2 is less than or equal to 2, then this one becomes true. Reason being 2 is equals to 2. Again, this one now covers the equal part. So you can have 3 is less than or equal to 3, that one becomes true. But again, 1 is lesser than 2, that is true, okay? But 2 cannot be less than 1. This one will throw the answer here is false. The answer here is false. The same thing with greater than. We have 3 is greater than 2. This one is very true, but does not cover the equal part. Okay, so 3 is greater than 3 will throw a false because it does not cover the equal part. So when we say 3 is greater than or equal to 3, then this one is true. Reason being, again, greater than or equal to covers the equal part. It is inclusive of the number that is equal, the equal number. Then the equal to here. Remember in programming, we said a single equal sign is what we call an assignment operator. I repeat again, a single equal sign. If I put an equal sign like this one, it is not an equal to operator. It is actually simply mean you're assigning whatever value that is on this side to the variable that is on the other side, okay? So the equal to operator here is double equal sign. This is to simply mean 3 equal 3. This one will give me true, this one will give me true, but 2 cannot be equal to 3. This one will throw the answer here will be false. Then not equal to is an exclamation mark with an equal. That means 2 is not equal to 3. This one is very true. Okay, but 3 is not equal to 3. This one will bring you a false because 3 cannot be equal. 3 is actually equal to 3. So these are the 6 comparison operators that you're going to use. We have the less than. We said less than does not include the equal to. If you want to use the equal to, then you say less than or equal to. Then we have the greater than or equal to. The equal to is double equals. Remember, one equal sign is the same as assignment operator, and then an exclamation and an equal, it simply means it's not equal to. These operations are very key when we'll be talking of arrays, when we'll be talking of loops, and you'll be able to understand that a simple error like adding an equal and less than or equal to changes the functionality of the whole loop. Just emitting the equal to here then changes the whole loop. Okay, so you're going to see more of this Boolean data type, especially when you go with the loops, but it's good you understand this comparison operator. For us to be able to store them, remember we talked about int. When you're declaring an int and you say int a, we assign it to 56, we have a string. We talk of s is equals to, maybe call it Nancy. Okay, that is how we declare different data types. We talked of integer, we talked of long, float, double. In case again you're not familiar with what I'm saying, then you can go back to the previous video and see how we declare variables. But for the Boolean now, this is how we declare it. This is Boolean. And say, remember, this is small b. This is because I'm using word. That is why it's capitalizing on my b. So this is supposed to be small b, Boolean, sorry. And say Boolean a is equals to, maybe true. Okay. Boolean b is equals to this. Boolean c is equals to false. Okay, again, you can store. We've said for the Boolean data types, they can only take two things, the true or the false. So you can initialize. When you come to initializing the Boolean, this is how we do it. Again, we said Java is very case sensitive. Once you change this one to capital B, you've already declared a different thing. So for Boolean, this is how do you declare it. Now, Boolean have their own logical operators. And these logical operators are four. We have the not, we have the and, we have the or, we have the exclusive or. Now, if you say when you want to log in to a certain system, okay, the first thing that you're asked is a username and a password. So for you to be able to log in, your username and the password has to be the same. Okay, once you enter a wrong password again, you're not able to log in. Once you enter the wrong username, you're not able to log in. All those are what you call the Boolean or the logical operators. So not is negating. We simply say it's negating. So if it was true, if for example my statement was true and I say not true, not true, then not true is simply false. Okay, so if I'm negating this column, okay, so if we say not true again, this is false. Okay, if I say not false, I'm negating false, which is actually true. Okay, if I'm negating false again, this is true. The not is actually negation. We call them in discretion mathematics, this is the sign of negation. You're just negating. If it is true, the opposite of true is false. If it is false, the opposite of false is true. So this is the negation operator. Then we have and. And can only be true when the two statements are true. I want you to always remember this. When you're logging in, you have to enter your username and you have to enter your password. And it's only when your username and your password are correct is when you're able to go to the system and you're able to log into a system. If anyone is wrong, say the username is wrong, say the password is wrong, or both of them are wrong, you're not able to log into a system. This is simple. If this one was my username, if I call this one username and I call this one password, okay, so true, a username is okay, the password is okay, so and you're able to log in, which is simply true. So if the username is okay, is true, and the password is wrong, then you're not able to log in. So this one will give you a false. Sorry, this one will give you false. This one will give you false. Okay. If the username is false and the password is true, then again, you're not able to log in, so it gives you a false. Okay, if both the username and the password is not correct, then again you cannot be able to log in. So and is only true when all the operations, when all the statements are true. true. When all the logical statements are true, which means if you are using the username, the password, or even the email address, they can only, when you use an AND, it can only accept when the username, the password, and the email address are true. That is not the same with OR. When you're talking of OR, is either both of them are true, you can say, if the user enters the username, or you can use now the email address. If it's either a user can log in using the username or the email, simply means they can use both. So if both of them are true, again, you can be able to log in. So true. So if one of them is true, so if username is okay and email is false, again, you can be able to log in. If the email is correct and the username is wrong, you are going to log in. But if both of them are wrong, then again you're not going to log in. Simply means when you use the OR, you're simply trying to say until both logical operations are false is when the whole statement becomes false. But as long as one of the logical operation is true, that statement is already true. That is OR operation. Then we have the exclusive OR. Rarely have I seen it used, but we're going to see where we can actually apply the exclusive OR. Exclusive OR happens this way. As long as if this is true and this is true, this one becomes false. This one becomes false. If this one is false, this one is false, this one becomes false. Okay? Any other condition is true. It's as simple as that. Any other condition is true. So we are saying if both logical operations are false, then it's a false. When both logical operations are true, then it's also false. Okay? So, but if either of them is true, then either of them is true, they do not have the true or something, then the exclusive OR simply returns back a true. It's very key to know the negation. We'll be using it a lot. It's very key to know and when you're using and, I repeat, and only happens when both conditions or both logical conditions are true. Any other condition, as long as it has a false inside it, then it becomes false. The other way around is true for OR. As long as one of the logical or both of the logical operations are true, then it will always return a true as the answer. Exclusive OR, as long as both conditions are either true or false, that is a false. Any other conditions throws a true. So we are going to be working mainly with ifs, but for the next session, now we're going to do a practical example on how you store your Boolean data types, how it returns. We're going to do several practicals on the not, the and, the negation, the and, or, and exclusive or. Again, thank you for watching. Keep learning, keep practicing. I can't wait to actually go to dig in and do a little bit more of coding with Boolean data types. Thank you for watching. Like and subscribe.